Good morning, everyone. Let's learn decimals today. So, what are decimals? The decimal number system is the standard system for denoting integers and non-integer numbers. Fractions with denominator 10, 100, 1000 are called decimal fractions. Thus, 3 by 10, 3 by 33 by 100, 227 by 1000 are all decimal fractions. They are written as 0.3, 0.33, 0.227, respectively by using a point called the decimal point. The place value chart contains places for the digits of whole number and such as fractions whose denominators are 10, 100 or 1000, etc. To separate whole numbers from fractional numbers, a small dot, that is decimal point, is put between the ones place and the tenths place. It can be observed from the place value chart that each place just right to the given place is 1/10 of value of a given place. Expanded form of decimals. For example, you have a number 235.456. How to expand this? The whole numbers 235 will be expanded as it is. So 200 plus 30 plus 5. Now 456 being a decimal numbers will be expanded as 4 by 10 plus 5 by 100 plus 6 by thousands. Or you can say 2 hundreds plus 3 tenths plus 5 ones plus 4 tenths plus 5 hundredths plus 6 thousands. How to convert a decimal into a fraction? For example, you have a number 25.230. How to convert it into the fraction? Follow the steps given below for converting a decimal number into a fractional number. Write the decimal without the decimal point. For example, here we have 25.230. We have to write 25230 without a decimal point. Write the denominator of the fraction by putting 1 in the beginning and the number of zeros at its right equal to the number of digits to the right of decimal point in the given number. For example, we have 3 digits after decimal point, so I will write 3 zeros here. Simplify the fraction and write the fraction in its possible lowest form. Here you have another example, for example 245.225. I will write the whole number without decimal and I will put 1 and put the zeros like we have 225, it means 3 digits after a decimal point, so I have to write 3 zeros as fraction. Like and unlike decimals. We know that fractions having the same denominators are called like fraction and the fractions having different denominators are called unlike fractions. Similarly, the decimals having the same number of decimal places are called like decimals, such as 22.8, 6.5, 222.8. You can see after each decimal we have only one number. In unlike fractions, the decimals having different number of decimal places are called unlike decimals, such as 42.3, 8.54, 422.488. Here you can see that after each decimal we have different places, we have different numbers. In the first number we have one number after a decimal. In the second we have two numbers after decimal, and in the third we have three numbers after decimals. It means like decimals are those which has same number of decimal places, and unlike decimals are those which have different number of decimal places. While grouping the decimals into like decimals and unlike decimals, only the digits or places in the decimal part of the decimals are considered. The number of digits or places in the whole number part of the decimal are not considered. Now is conversion. How to convert unlike decimals into like decimals. We know that the addition of zeros to extreme right of a decimal part does not change the value of the decimal number. For example, we have 8.3 which is equivalent to 8.30, which is also equivalent to 8.300, which is also equivalent to 8.3000. When we have to convert unlike decimals into like decimals, we have to balance the numbers after decimals by putting zeros, as it does not change the value of the number. Such decimals are called equivalent but unlike decimals. So without changing the value of a decimal number, the number of decimal places can be increased simply by adding a required number of zeros to extreme right of its decimal part. Comparing decimals. In comparison of decimal numbers, first we compare the whole number parts of the decimal number. If the whole number part are equal, then we compare the extreme left digit of the decimal part of the decimal number. If they are equal, then we compare the next digits and so on. For example, we have an example 21.23 and 24.78. We have to compare them. First, we compare the whole numbers 24 and 21. So you can easily find out that 24 is greater than 21. Therefore, the answer is 24.78 is greater than 21.23. In another case, you can see we have the whole numbers same, equal whole numbers as 71 and 71. Only the decimal points are different. So let us compare them. Here the whole number part in each decimal is equal, that is 71. So we compare the decimal part, that is 0.25 and 0.56. You can easily make out that 56 is greater than 25. Therefore, the answer 71.56 is greater than 71.25. Adding and subtraction of decimals. For adding or subtracting the decimal numbers, we arrange the numbers one below the other such that the decimal point in a numbers are in vertical line. While arranging the digits of the decimal number, they must be put at the proper place. All vacant places should be filled in with zeros. For example, we have to add 65.251, 32.72, 4.9 and 22.64. Arrange the decimals in columns so that the decimal points are in a vertical line. The missing places in the decimal are filled with the zeros. So, all the numbers placed are known as addends and the answer is known as sum. Here you can see that all the sum is similar as usual sums, but the decimal point should become at the same place where it is in addends. Therefore, the sum of all these numbers are or the sum of all these addends is 125.511. Similarly, in subtraction, we have to find which number is greater. We have to put that number on the top and the lower number under that. So the minuend being the number bigger is known as minuend because we are going to subtract some number from it. And subtrahend is the number which we subtract from the bigger number. And the difference is 27.331. Addition and subtraction is in the same way we do in the whole numbers. But the only thing is you have to place the decimal accordingly where it has been placed in addends or in minuend or subtrahend. Multiplication of decimals. Multiplication of a decimal by a whole number. To multiply a decimal number by a whole number, multiply the two numbers in the same way as we multiply whole numbers. Place the decimal point in such a way that there are as many decimal places in the product as in the multiplicand. You can see we have multiplied the process as we used to multiply with the whole numbers. But the thing is, when you multiply 4,123 with 230, you got an answer 8,78,199. But you have to put the decimal place. Just count the numbers after decimal. There you can see you have two numbers after decimal point. Similarly, in your product, you have to place decimal before two digits. Number of decimal places in multiplicand and multiplier. You have to observe after decimal how many digits they have. For example, here you can see you have a one number after decimal. In multiplier also you have one digit after decimal. It means one digit plus one digit, you have two digits. So in the product you have to write decimal before two digits. Here you can see you have two digits after decimal in multiplicand and one digit after decimal in multiplier. So 2 plus 1 is equivalent to 3. So therefore in the product you have to write decimal before 3 digits. In the third part you can see you have two digits after decimal and again two digits after decimal in multiplier. So 2 plus 2 is 4. Therefore you have to put decimal before 4 digits in the product. Now, division of decimals. Carry on the division as the same way as in case of whole numbers, ignoring the decimal point. Put the decimal point in the quotient just above the decimal point in the dividend. For example, here you have two digits after decimal point. That means in coefficient also you should have two digits after decimal point. If the last remainder is other than 0, write as many zeros in the right of the dividend as necessary to make the remainder 0. So you can find the remainder 0 by putting as many zeros after the decimal point of the quotient so that you will get the remainder 0. Hope you have understood the chapter. Thank you.